Hello, today we're diving into something really curious in mathematics, the Collatz Conjecture. The rules are simple enough for a 10-year-old to understand, but some of the smartest mathematicians in the world have been trying to prove it for almost 90 years, and still no one can prove it. Here's how it works. Pick any positive whole number. If your number is even, divide it by 2. If it's odd, multiply by 3 and add 1. Then take whatever result you get and do it again and again and again. Keep going until you reach 1. Let's try it with 6. 6 is even. Divide by 2. We get 3. 3 is odd. 3 times 3 plus 1. That's 10. 10 is even. Divide by 2. That's 5. 5 is odd, times 3 plus 1, 16. Then 16 becomes 8, 8 becomes 4, 4 becomes 2, and finally 1. We reached 1. Every time, every number we've tested eventually reached 1. Try it yourself. 27, 45, 91, they all collapse down to 1. Mathematicians have tested this on computers with massive numbers, billions of digits long, and every single one still ends up at 1. But here's the strange part. Even though it seems to always work, no one has ever been able to prove why. And still, the brightest minds on earth haven't figured out how to prove it. Now, let's see how this looks in Python. We define a function called Collatz that takes one number n. We create an empty list called sequence to store the numbers, start a loop with that continues until n becomes 1, add the current number n to the list, check if n is even. If even, divide by 2. If odd, multiply by 3 and add 1. And the final number 1 to the list. Return the full sequence. Run the function with 6 and print the result.